Welcome, everybody. And in this live stream, we're going to be talking about escrow and specifically escrow contracts on the Metanet and how to make them a composable building block for all manner of future systems. So, yeah, I just want to try to make it easier for everybody who is working with Metanet primitives so that they can they can make use of escrow. And I want to talk through the best way to do that, starting with some high level sketches. Because escrow is essentially a way to ensure that everybody gets what they want out of a transaction. Nobody can pull one over on somebody, right? And that's essentially what I want to talk about. And then I want to start by sketching out you know some primitives, some capabilities, some components, some interactions, some properties, some architectures for this. And then I want to apply that by writing code and having fun. Because, if you're not writing code, then you might not be having very much fun sometimes. So, hello, Jake. Good to see you on. Hope I can. Hope my audio is working. I didn't actually test it beforehand like I normally do. I realized that right as I was running the intro. So let me know if I'm audible. What I want to do to get started here is okay. Yep, that's visible. I'm going to go to text edit of all applications, and I want to just write down the things that are relevant to an escrow, because we can sketch out some fun things from this foundation. An escrow has, and I'm going to come up with some new terms here so we don't get confused. An escrow has and I'm going to be kind of I'm going to be building this in a way that's kind of useful across a wide variety of contexts, and then we can see how generalizable we can make some of these primitives, so we can create an easily accessible library by the end that everybody can use. An escrow has a seeker of services, a person who wants something and who a person who wants something, a product or service, and offers money. An escrow has a provider. No, they have a platform. So I guess you have a platform. Takes a fee. And then you have a furnisher who furnishes who provides a product and accepts money. So when I think about the ideal user experience of an escrow system, I think of the models for each of these three entities, and then I think of the things that each of them can do as they interact, so that they can coordinate an effective escrow system. The goal is going to be to design something that that is enforced by the Bitcoin the BSV blockchain network in terms of sCrypt. So we'll have a contract that makes sure certain rules are followed. So a contract. Oh wait, why is there a little dash right here? That's not right. Okay, that's a fundamental entity. Then there's a contract. The contract might say something like, um, 2 of 3 must agree, only because that rhymes. 2 of 3 must agree. Money goes in from seeker. Right, and then money may go back to the seeker with the platform signature, or it may go to the no, it goes to the furnisher. Right. So that's essentially the idea. Service fee to the platform for providing escrow services. And in this case, we'll make some of the more fundamentally thinking people about BSV happy by saying money equals Satoshis. So for a simple contract, we can say money would equal Satoshis. As a seeker, I can create this contract, right? Offering money. I can actually, we forgot a very important thing up here. If the seeker and the furnisher are okay, then they don't need to sort of involve the platform, right? So as a seeker of services, I can, right, create contract offering money, increase the bounty later, cancel before accept, sometimes I can approve a furnisher depending on the context of this contract. If it is a unpermissioned contract where anybody may accept the bounty, there's different ways of going about that, right? But if a furnisher wants to be involved, wants to request services, I can make that happen. I can accept them as now you're on the contract. Nobody else can claim it, right? As a seeker of services, I can put up the money essentially, and then what else can I do? If someone wants to work for me, I can accept it. Um, and then I can approve completed work. Um, I can also dispute completed work. And now thinking procedurally about how we're going to code this, I should be able to list active disputes. And I should be able to, and of course, platform will be involved at that point. You would provide evidence, et cetera, et cetera. But so if I disputed something and then I got my money back, I should be able to get my money, right? Let's go to the furnisher of services first, because I think that's fairly important here to define before we do the platform. It's going to be easier. A furnisher of services can list all open contracts. They can potentially, I guess you could say, bid, or well, the money is already offered though, right? So you could build, like, there's a lot of things you can build, right? I want to be as generalizable as possible without sacrificing simplicity and ease of use for a new library that allows these entities to interact, right? If I bid on something, then the sort of the seeker would need to accept my bid and put up the money before anything else happened. So I don't know about putting bids in place here, although that could be really cool, and I kind of like it. So I don't know. Let me know what you guys think, if I should try to put bids in here as well, and then track those, and then people can turn on and off different modes of this, or whether I should try to keep it simple. I like both approaches, and I think we will need both eventually. Obviously, I can list contracts. I can, if it's approved, right? I can sort of uh, start work on a contract. Mark work is completed. Receive pay for approved work. I can also raise a dispute, list active disputes, and claim money from a valid dispute. I think that's pretty good for the seeker initially, but let me know what you think, whether I should put bidding and that type of thing in so that different people can provide bids openly in the contract UTXO. If you tempt me too much to build that, I might. I think it would be very useful in certain cases, and you could set the maximum number of bids, etc. A platform can essentially do everything related to disputes, right? So list disputes needing attention. Adjudicate. Am I going to spell that properly? No, I am not going to spell that properly. Decide a dispute. Is that all? Is that everything a platform can do? If we have all of these three things, do we have a complete system? Will this work? Can we code this? Maybe. What do you guys think? I'm going to check the chat. Let's see. How do we... Okay, so looks like... Hang on. Let me do this. And then I'll go through the chat. Good to see you, Sean. And let's see here. So we're saying here, describe work, upload photos of the specifications. Yeah, so that's going to be in the contract, right? So there's going to be like arbitrary data fields all over the place. And that way you can say like, you know, specs, and there's like this basically byte string that you can put whatever you want. That'd be really cool. Let's see. We have bids would be pretty cool. I that's kind of what I'm thinking as well. All right. So let's see. We've got. Well, people will choose their work and who they want to do it, and you know, I think you can certainly set things up however you know. There's going to be different modes of this, right? Like in a non-permissioned mode, I think you could you know you could set up different rules where parties interact directly. In a permissioned mode, you could have the platform have to approve kind of most things. But either way, I think we're in a place where we can set up a lot of these things. Let me go back. All right, going back. I want to write some code, and I think we have a starting point. So our starting point is going to be the meter app. Whoops, that doesn't work. Let's learn how to use the terminal first. This is going to be Babbage Escrow. Is that already a... Oh, duh. See, once again, terminal in in 2025 is hard, guys. It's just really, really hard. Just copying a directory here, I could have forked the repo. It would have taken less time. Making a new project based on the meter project. So if you want to see my starting point, maybe even follow along, we got meter here. I'm going to use the back end only. I'm not going to use the front end. As you'll see, I'll disable it. What I like about meter is that it incorporates sCrypt contracts into a overlay network. And then it's also got this backend package.json file. So I think what I'm going to do is export some things from, mod.ts in this package.json file that, I'm going to use for this. And I can publish this on NPM. So I'm publishing a library that incorporates an sCrypt contract into itself as compiled code on NPM. And it won't be just called this, it'll be called, the name of my package. But then because it uses Lars and cars, I have topic managers and lookup services. And this can be a deployable artifact in the context of, running on Lars and cars for running an overlay. And that way the overlay can track things like open contracts. So because, right, well, let's zoom out a little bit while this is working. When do you use an overlay? When do you use baskets? Well, there's different ways we can coordinate the state of the system. State management 101 for Metanet applications. Well, if you want to do everything locally, then you should use baskets. So if you just have state that is relevant only to yourself, then your UTXOs right? If you have a two-party system or direct updates, you could do it peer-to-peer. You could just send messages. Right? And that's two parties. So you got one party, two parties, and then you have overlays. Coordinate state across many people. So that's our state management 101 lesson. We basically want to use overlays when we have 3 people or more. Overlays are also useful for open predicates. So because we're having an open contract, so an open public, whoops, did I just, I messed up my window. Here we go. Right. So an open public bounty or global offer is always going to be on an overlay because everybody can see it and everybody can find it and they can leverage it. So yeah, that's how we're going to get started. Okay, so meter. We talked about some structure, we talked about some architecture, we talked about some conceptual sketches and random blueprints that we have to put together. Open this up and start modifying it. First order of business is to remove all the stuff we extraneously copied that we didn't need to copy. Oh, and the whole front end goes away because we're not building a front end. We're building a back end library here. And we will try to test it, right? We'll have some tests. But front end is implementation specific. It's what are you going to use this library for? Who is doing what valuable work and who is mediating disputes, et cetera, et cetera. And then we got all these artifacts from all the times that I've released the meter application, and I'll just delete them. Okay, so we got a back end. Deployment info, we're going to modify this already. So BSV app, there is a topic manager. There is a lookup services. factory. Hydrated with Mongo, that's going to be fine. No front end in this project. So again, using deployment info.json BRC 102. Check it out if you haven't. Local Lars is going to run only backend. And cars to deploy, this is Degan's thing. Cars to deploy here with a different project ID. And we're only deploying, once again, a backend, so therefore this front-end hosting method, I think, is not required. Oh, and then there's just a random other one. Okay, well, we'll get rid of this one too. So we got one way to deploy this application on mainnet Babbage cars. And we can also run it locally with Lars. Backend only. Got our topic manager, lookup service, and smart contract here. Those are the main components, except for the business logic that we need to write within the actual backend itself, which is entirely new. Okay, so at the root level, we just want to make sure, general practice. I bet you that both Lars and cars are completely out of date. So BSV Lars at latest. Let's see if this goes up. Currently it's 1.3.1. And if I press enter, now it's 1.5.0. And for cars CLI, make sure you use the latest for these guys. If you don't use the latest one, then it's really going to make you have a really bad day, especially if you're on Windows 1.2.4. So yeah, definitely, use the latest deps for those on your root package JSON of a BRC102 project, Lars and cars CLI. Okay. And probably after you watch this live stream, the versions are going to be even higher. So don't just look at these ones and use these. Although, yeah, just use the latest steps. Okay, so we got that mainly set up. I need to initialize a new Git repository. Git init. Whoops. No. Git init dot. Git remote add. Wait. That's funny. Okay, rmtech rfi dot. All right, let's we can do I. So we add an origin for our GitHub. Babbage escrow. And now we have all these things set up the way they need to. Backend has artifacts, dist, node modules, etc. And we'll need to do some little housekeeping things, but I'm hoping to get to the point here where, okay, we got contracts, we got script templates. I don't think we need that here, but we will need to update a lot of this to just be reasonable, reasonably good. Yeah, so we're going to need to set up a escrow contract. That's going to be in types in sCrypt. We need to delete this dist folder. Again, node modules. And then lookup services, we got escrow. And we'll have to rename all of this. Just as correct. all of this will be refactored. So we're making a new escrow system here. And you guys said you wanted to do bids, so I'm going to add that into the plan before we get too started. Bids are essentially going to be a thing that so we'll set the you can set your work descriptor data and your number of bids. So actually, let's make this a little bit more clear. So you're setting your arbitrary work descriptor data, so what you are working on, et cetera, et cetera. Configure number of bids. Mode, etc. Okay, so now that that is the case, cancel before accept, approve a furnisher. Okay. So now we're going to get into the details of this. Can a furnisher just accept the contract? Sometimes, sure. Can a So sometimes the contract will automatically accept a person starting work. And sometimes there will be only one furnisher and they just get approved or not. Although simplifying that down to just having a list that could have a maximum of one bid in that case could be good. But then, yeah, that can be that way. Okay. Then a furnisher could place a bid on a contract. Then there's the idea of permissioned versus unpermissioned systems, which is the final degree of complexity that I would like to add. This relates to whether work must be approved by a platform. So can a platform or must a platform approve the starting of work in a particular case? Some platform, sometimes the answer is let the platform approve, and they must approve everything. They must even go so far as to match bids to, or well, the overlay can do that pretty efficiently, but for regulatory reasons or whatever, sometimes a platform needs to approve a person starting work on something for somebody else. Maybe the platform is responsible for checking their qualifications or something like that, I suppose. Different ways to go about architecting this. Maybe I'll leave that for next time, though. I think adding platform-based approvals and permissioned mode to this, where the platform gets a list of all the unapproved, bids, and then can kind of match people. I think that's not as important, especially given the nature of the tech, right? Like we have an open predicate system. We have a way that anybody can pick up any work as long as it is approved by the person who started the contract. the original seeker of services. If that original seeker of services approves work, probably we don't need to think too much about that yet. There are some cases where we may need to, and there are some cases where it may be required under regulation, for example, that a uh, particular seeker of work must perform particular uh, vetting steps. For example, the verification of an identity certificate attesting to the legitimacy and licensure status of a particular furnisher of services. Um, Maybe that's even all that's required. Therefore, let's proceed. So bidding has been added to the plan, and we have a basic contract already. I've just been renaming some files and getting all of this stuff, into the place where I hope it can be useful. I'm going to delete a lot of this, and then I want to create some new classes. So I'm just thinking in file names and directory structures right now, and then eventually I'll obviously dig into the specificities of interaction within each of these files. I want a new folder called entities. And in this entities folder, I want a new file called seeker, which is the class of seeker. And I want a new file called furnisher. And I want a new file called platform. All right. So here we are, right? Here we are at the very beginning. Mod.ts. Let's export everything. What do we want? Well, we want to export an escrow contract from that correct file name, an escrow artifact from this non-existent file, can I just, do that? Yes, I can. Cool. Great. Confirming, why are we exporting the docs as its own? We don't need to do that. Wait. Escrow lookup service factory is exported from the lookup service factory. And this is actually just exported. They can't do that. Okay, and then we're not exporting a script template because that doesn't exist. But we are exporting all the types, and we are exporting right, we want seeker, and we want oh, I see. We want furnisher. And platform. So if we export all of these things, and yes, I know some of these aren't yet defined, but the theory is that now we have all the files that we need to write our core of our implementation of everything forever. Maybe that goes a little far, but I think we're very close. The contract will be containing various methods. And to start this, we need to install our dependencies. And we got escrow contract. We got to get this. Yeah, it's going to, but now I can import this. So that's nice. All right. So we're exporting a default class meter escrow contract that contains some stateful properties. And you can construct it, and you've got some very simple methods here. But we can consider what's actually going to be here. When we think of contracts, we think of on-chain values. We think of things that are available publicly. There are a few different ways to go about the coordination of a contract, including, the linking of identity keys to the on-chain interaction, etc. But all of that can be done privately. We don't need to publish all of the identity keys and everything like that in an sCrypt contract. You can use derived child keys, as we'll see, and it makes it a lot more secure. This is how some people are already doing smart contracts. So it's good that we're not using the identity key directly. However, Meter is naming it here, so we shouldn't do that. I'm going to have to make extensive references to existing code from all around the sCrypt ecosystem and also the coin flip contract in order to implement all of the things that we need. But I don't think the mental model of thinking in sCrypt is the best place to get started. I would like to fall back to my list of what each entity can do, and then try to start with some pseudocode for the classes that describe each of these entities so that we can then scaffold out from there and derive and make eventually concrete all of the things that we need. So let's make a seeker class then to start, because I'm looking at the sCrypt here and my eyes are glazing over. It's like, how can we do this simpler and better and do it the best way? A seeker has a wallet. Okay. A seeker has a wallet. And when we think of this first simple mode, we just need to write some initial code, right? That's the first step. a seeker knows which topic they are going to use. And which lookup service they're going to use. And maybe they even have a topic broadcaster and a lookup resolver. So they know what topic they're going to use, and can I default this? I can, and can I pass in this dot topic magically somehow? Oh, it takes an array of topics. In this case, there's only one. And if this dot topic is also, and this can even be defaulted to a new wallet client. See, we're figuring this out, guys, right? You can default every single thing. I don't have any wood to knock on. You can default every single thing, and I'm 100% sure that that's definitely going to work. Okay, so all of your parameters can be defaulted, including that one, and that one. And what about the one that's like last? You know, you definitely should, you know, do that one. Yeah. LS escrow. And if you don't provide it, then it's a new lookup resolver, and that takes nothing. So by default, right, if you want a network preset, if you want any of that stuff, you can do that way. But now, oh wait, cannot find name. Did I make, oh, sure. All right, fine. Right, okay. So now we have a wallet and a concept of which overlay we're working in. That's going to be a pretty common pattern. There are some, and maybe these should all be kind of last, actually, because there are some hyperparameters that a person might want to configure first. And we may want to put those in a constants file or a types file or something like that. The parameters relate to, you know, the service fee of the escrow platform in the case of a dispute or something. And by the way, we can talk about how the escrow is going to enforce fees that they charge on their own, you know, platform, etc., by the use of the lookup service and simply not picking up or not, you know, refusing to mediate, to adjudicate disputes that happen when fees aren't paid. So let's just think of a percentage fee that should be configured as part of the hyperparameters of the system. 3%? I don't know. 1%? You could even make it a flat fee in Satoshis if you really wanted to. Okay, so we got that information, right? When I create a contract, I am seeking that something be done. What do I? Some arbitrary thing needs to be done. And how much am I willing to pay? A number of Satoshis. Okay. And I promise that that there will be a TXID hex string or even an outpoint string. Yeah, it should be an outpoint. Right, and I presume this isn't imported. And we're going to import all manner of things, so just bear with me. I promise that if I, right, so this is async function, async method rather. If I have a thing and a bounty, then I can get a, yeah. I can get a outpoint that says now there's this contract that's on the overlay that, so you construct the contract, you create the transaction, get your own public key, construct the contract, create the transaction, register on the overlay. So that's essentially a seeker who can set that. Okay, number of bids. That's what we need. So it's another, once again, how many bids? 10? That's a lot of bids. 7? All right. I like 7. So you got a max allowed bids on a contract of 7. We'll say you get 1.3%. So we know it's not a scale from 0 to 1, but rather a 1 to 100. And I guess the service might want more money in the case of a dispute. Feels a little bit better. Okay, so there are some other parameters here that we're going to need pretty quickly. Like we're going to need to know what protocol once again, it's just going to be escrow, but that's important because we need to make sure that we are able to configure that. Now that I've created a contract, in theory, can I do that? I cannot randomize that. There cannot be, we'll think about that later. Okay, so Now, let's think. Bidding. I'm just realizing some of the implications of what we wrote down, right? So I've got this plan in my head, and I'm thinking through some of the details. Bidding is going to be a little more complicated, right? Because if it's a bidding-based contract, yes, there is going to need to be a mode. Yeah, let's think. So that's more fundamental, which means that goes up. So you got bounties, or so you got bounty and bid, right? If it's a bid, then you need to put up the money after you approve the bid. So to approve a bid, you put up the money at that point after you get your bids. Otherwise, you have a bounty, which is, hey, everybody, I already have this money. If you want this money, then do this thing. So that's different, right? And that's been a little bit wrinkle. It's been a wrinkle in my mind. We can't have wrinkles in our minds. It's not healthy. Well, I guess that means you're smart if you have wrinkles in your brain. But we need to think about, the implications of our decisions. Otherwise, we make bad decisions. So I can increase the bounty. That's cool because nobody does my thing if it's not enough money for them to care. When I approve a bid, only valid when mode equals bid. At this point, put up the money. Bidder. Do I send a message to the bidder? Yeah, I do. And I also update the overlay. Now, do I use messaging at all here, or do I just use the overlay? Maybe I should just use the overlay for everything. Might be simpler for the beginning, and then we can figure out more scalable, peer-to-peer direct interactions where necessary in the future, but I can get everything off the overlay as a bidder, so that's fine. Okay, so when I make a bid, okay, so if I want to approve a bid from the list, that's how that works. Then the contract transitions to active work state. So work is active after the bid is approved. Okay, the other option is I want to approve when it was a bounty. So somebody wants to claim my bounty. And then the question is, do I even get to approve in that case? And the answer is probably not, because if I get to pick who gets my bounty, is that cheating? If I put up a bounty and say, well, it depends on whether the bounty was like whoever does this first, and then I get like 5 answers to my question. But you should not try to start answering the question unless you're approved in this model, because again, there's escrow. Wow, interesting. It does get a little complicated, but I think this mode is also supported where I approve. Yeah. Okay. We don't want to overcomplicate things, especially at the beginning, but we do want to get to a working state. At the same time, we want to make sure that the working state that we eventually get to is ubiquitous enough to support the various models. I do think there is a world where I say I want something to be done for, and I'll pay $10. Somebody comes up to me, multiple people come up to me and says, "I'll do this for $10." I pick one of them, and then that's the one that gets to do it. That's like a thing that happens, yeah, maybe. Um, I can select a. So in that model, I should accept a solicitation. No, I solicited and then somebody accepted. I am approving in bounty mode. Okay, so let's think through the logic. We have a few. Okay, I think that clears up the issue with this pseudocode. If mode is bid, so if I don't know the amount that I'm willing to pay, that's really what it comes down to. Then I'll put one sat to begin, or put some token amount, right, to start the auction. Essentially, is what that is. Otherwise, it's not an auction. It's a solicitation. Oh, interesting. So the mode becomes bounty if you don't the mode becomes bidding if you don't provide a amount. And that means that the mode is not read only. You can write this at the top. If type of amount is not number, then contract type goes to bid. If you didn't provide an amount, then everybody bids. Bounty, rather. If you didn't provide a bounty, then everybody can bid. Okay, so that wrinkle has been resolved. We kind of figured that out. I made a contract. Now I have it on the overlay. I want to know all the contracts that I have that are not. Yeah, I just want to find all of my contracts. So get my contracts. What do I get back? Well, a representation of each contract in the form of some type that is not yet defined. It's a promise for an array of my escrow contracts. Boom. And then it's saying it doesn't know what this is. So I'll need to suffer in silence until we actually define that type with my compile errors. So what are we going to do? Well, we need to So we got this helper method to get the public key. Yeah. All right, well then go away. Okay, if we do that, then we can say getting one of our own public keys. Actually, don't even need that because do that. What's the protocol ID? Well, security levels 2. And it's the key derivation protocol. Key ID for now is 1. Boom. However, this is already a string. May as well do that. Okay? So it only does it once. In fact, we can make this code even simpler because we don't need to return it. Just say only if this is not already a string do we make it into this particular string. Okay. So now we don't have to do this logic every single time. Right? So first we get that public key. Okay. So now I can make a contract and I can get a list of my contracts. All right. Let's check in with the chat, see what everybody's up to. Okay, let's see. Platforms could also match furnishers to seekers. Yes, that is correct. And that is a mode of operation that we'll have to think about. Let's see. Does not compile properly in the Meter app. If you run the global version of sCrypt CLI-C, it might work, but I'm probably gonna find that out the hard way in just a second if it's not working. I'll have to check into that. Okay, and Yeah, Lars, latest versions should be a little bit more well behaved than previous ones. Um, we can get back to this stuff. I think we have the ability to do this now for these two functions. If I tell this a given contract, I should be able to cancel. So if I didn't accept work yet, so I didn't say it was okay to start, right? Then I should be able to cancel it. And that's just going to register the transaction with the overlay after it cancels. Okay. Just pseudocoding some of these things, starting to introduce some code that is reasonable. So contracts can be in either initial state, starting to come together, right? Initial, active, submitted. So active work submitted. What other states are applicable to a contract? Obviously disputed by seeker disputed. Furnisher disputed. Or resolved. Contract is resolved when the funding has been has been or is about to be released. So those are some states that I think the contract can be in, and we'll model that with sCrypt. I want to rename this, it's bothering me. Constants.ts, so meter record, let's say escrow record, txid output index. Yeah. We'll have a lot of things in here, right? Seeker key. State. I don't see particularly why we would track created at timestamp. The rules of the contract are not time oriented and specific to the particular lookup service, not derived from the blockchain at all, so therefore won't be tracked. Okay, UTXO ref. Okay, all right. One thing we need to do as well is install the latest version of overlay services. So just thinking, if this is going to be our type, I don't see why it shouldn't be our type that we actually use in the in our implementation. Bounty amount, of course. You got bids and bounties. And if you're going to have bids, Each one is from a person who has an amount on the bid. Accepted bid could be tracked as well. So for type bid, initial is 1, or initial is here with 1 Satoshi in the contract, so very small. But then people can bid, and then it only goes to active work when somebody accepts a bid. Probably you're going to want some data. What is that called? No, it's not always a proof. Somebody, when they put a bid in, they can put, maybe some plans. So you got a work description. When you put a bid, you say, I'll do this, and here's my plan, and here's my bid. So should be able to provide something at least. And it could be encrypted. Your bid could be encrypted for the key of the, of the person, but that's context dependent, I guess. Maybe we could enable it. We could just, if the only issue is in case of dispute. In case of dispute, how can I reveal and prove that that's actually correct? That gets complicated. Let's just allow it to be public for now. I imagine. Somebody will figure out more in-depth things as we move along. All right, so we defined some of these constants. Probably we want to make a. No, let's not get too complicated with it. Okay. So we've resolved this. I should be able to import escrow reference from record. Not from that, but from that. So what I'm really dealing with here are records. So we got the record of an escrow contract. So we build that up, right? And what we want to do now is we got rid of this comment, kind of actioned it. So let's see. And create an offer, and I can accept. That's on the other side. To increase the bounty on an existing contract. So I can list all of my contracts. How do I increase? Do I need that? I don't know if I need that. So we're going to spend. We want to verify this is a type of bounty, and it's in the initial state. Should be pretty simple to do that. It's coming together, just trying to keep all the pieces kind of where they need to be. Okay, so if I want to approve a bid from the list, why is this private? It's async. It's not private. It's different. Okay. And this would tell me what? Let's think. So we got to zoom out. Seek is the initial thing, and I don't get an output string. I instead get a whole record, which contains a TX ID and output index, mind you. Right, we're dealing with these records now, which is the correct way to go about this. It's the most intuitive way for the consumer, I think. I can approve a bid. What am I going to do there? Set bid as set bidder key as furnisher. State goes to active work. Got to make sure also got to make sure that the bid refers to an actual bid. So that's how we're going to code that up, right? To approve a bid, that's what happens. Now, the other thing was Oh, and you got to put up the money. Right. So at that point, you've approved a bid and you need to put the money up. Uh, and there's got to be a Boolean. Like, do bounty solvers need approval? And then if they don't even need approval, then there's the question of, okay, does the competition go until the very end? And then actually it transitions to, it doesn't even have an active work phase. It just says, bounty solver comes up and says, hey, I solved it. There's like a time period where the escrow. Okay, so bounty solvers need approval. That's a wrinkle, right? If bounty solvers do need approval, then they get approved and it goes to active work, and then they submit their work, and then the escrow can weigh in after it goes to work submitted. But if bounty solvers do not need approval, then essentially it goes from initial state all the way to work submitted. Then there's got to be a verification period where the initial proposer has, say, a certain fixed amount of time to approve a bounty payout, right? Basically to authenticate, yes, in fact, this person did legitimately claim my bounty. And if they don't approve it within that time frame, then it automatically, it can be disputed by the the solver, the furnisher of the solution, with the platform. That would seem to be the way to do it. You're depending on the, who can spend this first type dynamic in the one case. And when bounty solvers do not need approval, that makes sense. When bounty solvers do need approval, then it's more like a bidding type contract where, yeah, I've already put up the money. I've just decided how much I want to pay up front. Take it or leave it. You want to take it, you still have to talk to me before you start working, get my approval, and then, complete the job. I think that's the full spectrum of solutions I want to enable here. The only potentially remaining class would be when the platform needs to approve, or when the platform can, approve on behalf of the of the seeker, so that the seeker doesn't have to select among the bids or select among particular, it's kind of when the platform is weighing in a little more among either bounty solvers or bidders, right? So here it's the onus is on the seeker to approve, and then there's another Boolean, yeah. So bounty solvers need approval, and then there's can platform approve, and maybe we could say always. So like either the platform or the seeker could approve, or the platform must approve instead of the seeker, right? So coming together here. Some generalizable building blocks for escrow systems and contract stuff. Uh, Approved bounty solver. You need a contract, right? And you need the bounty solver who solicited. In that case, isn't that just a bid, but you put the a bounty is just a thing where the money was put up front, and it's just like bids. It's just that they can't. Okay, because when we get to the other side, when we actually code up the pseudocode for the furnisher, which will be next, we'll be in a position to think about how best to architect the placing of bids and accepting of bounties, etc. Because I'm thinking, obviously, that there can be multiple candidate bounty solvers who have not yet been approved if bounty solvers don't need approval. And when they do need approval, when they do need approval, right? So, yeah, there can be multiple when they do need approval as well. See, we're kind of repeating ourselves here a little bit, aren't we? No need to put up the money. So yeah, the dynamics are only different because in this case, everybody has knowledge that the person already has put up the money ahead of soliciting any bids, and the bidders don't have the ability to impact the you know end result. It's a matter of just which one gets to do the work at this fixed cost. Very interesting. Okay, so we have to go back to our data structure, which is important, right? No, not here. We have to go back here. So again, yeah, we figured out we needed a settings, right? We also know we need the escrow fee. Bounty solvers need approval. And then it was what? Service percentage? Oh, max allowed bids. Escrow service percent. Okay. So bounty solvers need approval. And then we decided platform. So yeah, you could set max allowed bids to 1 and bounty solvers need approval to false. Sorry, to true. Bounty solvers need approval would be true because, and then there's only one, meaning you just accept one bid and then, no other person can bid until you either approve or reject. Does that mean there should be a reject bid? And then you say, nope, it goes back to the initial state. Right, so reject bid or remove bid. Seeker can reject bids. Yeah. That's reasonable. And then the approval mode need to be seeker approves, seeker or platform approves, or the platform is the only one who can approve. So that controls the final variable, which is, does the seeker need to approve when bids have, yeah, it's what it sounds like. Okay. I think this is a fairly comprehensive structure at this point. So bids can apply then to both. Bids can apply to both bounty type and non-bounty type contracts. Unless bounty solvers do not need approval, in which case there's a time element, right? Because if bounty solvers don't need approval, then the seeker needs a set time to approve the provision of services. The max time in seconds that the seeker or blocks in nlock time kind of domain values, max time that the seeker has in order to approve a given set of requirements, a given bounty. Otherwise, someone can dispute. So, for example, if I go to a contract where bounty solvers do not need approval, and then I provide a particular solution, I do a particular thing, I claim that it is done, what is to stop me from doing that all the time? What is to stop me from saying that I have done every contract all the time? Um, if I do that, then it gets even more complicated. But I could require the platform signature when work is submitted to prevent somebody from unilaterally generating a new key and just locking the contract up. Or we could go back to solver's bonds and it's like, if it so happens that you're wrong. That's funny. Yeah, we could do that. Why not? I'm up for a challenge. I think we could model that, and it would create a deterrent effect to you know to the system. You lose money if you lock up a contract. I like that type of approach. So essentially, how that works in this case is the furnisher of services, when they claim it's complete, in the case of a contract where the bounty solvers do not need approval, they have to put money into the contract, which they get back when it's done, when it works, right? But if the solution is not acceptable to the provider, the seeker rather, and if the platform sides with the seeker in that case, then the money that they put in is lost. It goes back to the contract, and the contract goes back to a unfulfilled state. The other question is whether somebody could dispute, so there should be a deadline on all of these, because we don't want we don't want a furnisher of products or services to you know okay, let's bring these abstract concepts to life here, because we have a few of them. We need to track the required non-approved furnisher bond amount. So when a non-approved furnisher accepts, they put up a bond, right? Uh, okay, just making some updates here to our logic. But I think we've successfully captured all of the things that we need to capture. Seekers can approve bounty solvers. So we got bounty solver. You can increase the bounty. If you approve a bounty solver, you're going to and when we get to the other side of it, it's going to be easier to understand how that works. Set the key as the furnisher. Okay, that's the pseudocode for that. Any validation? Verify it can be correct. Okay. To approve completed work, you need an escrow record, and you need to verify. So the state will actually be in submitted work already because the furnisher has marked it as submitted at this point. Actually, I don't think we need that additional state. I've got a few things in my mind here as I'm thinking about this and doing this stream and everything. I don't think we need a separate state for timed out because it's a form of dispute. Okay. Verify the state is there. State goes to resolved, and that way the person can just spend it and get the money. Okay. To dispute work, you verify the state. So state must be active work with timeout expired or submitted work. Okay. Is there going to be dispute evidence? Well, maybe, who knows? That can be done off chain. Generate a dispute ID. Oh, what could possibly go wrong? You know, if you're malicious, you could create a dispute ID that is the same as an existing dispute ID. So therefore, the dispute ID should be the TX ID of the initiating transaction of the contract and will not be generated. I'm thinking this because we got to reference this. So maybe you provide the evidence and TX ID, and then you've disputed. Okay, dispute work can be done when the time has expired for when the work was supposed to be done, even if it's still active and not yet submitted, or when it is in the submitted state but it wasn't good. Okay. I can list my active disputes. How does that work? So to list active disputes, we have this get my open contracts function. And if one of them goes to resolved, then, there's that. So not the worst thing. Let's think about we just need a pseudo function right now for claim and it's just going to spend the resolved UTXO. So if you, what happens to the contract? Okay, what is the experience here? If I create a solicitation for work, the question is, do I want, so I got my money back. And maybe I have a question. Maybe I wonder whether I should, so I get my money back because somebody screwed me over, or they tried to. So basically what happened was, say I wanted a package delivered. I said, I have this package, I want it to be delivered. A furnisher said, sure, I will furnish the service to you by delivering you this package where you say you want it to go. And then they don't get it there in time. So you dispute and you go to the platform, and the platform says, yep, looks like they didn't deliver it in time. You get your money back, right? You get your money back, and I get a fee for disputing. The platform gets a fee for mediating the dispute. In that case, the contract with that particular entity is resolved. There's a question of whether, do I still want my package to go where, or I mean, it's okay, forget it. You failed. And then if this was in fact another example, not fitting well to the package example, but if this was a situation where bounty solvers don't need approval to start work, I could just take the money from the bond, which the solver put up, right? The solver's bond, in order to, and you can check out the Bitcoin CPU video for a full breakdown of the solver's bond and how that works. Technical breakthroughs in the Bitcoin CPU, June 2024, London conference. But yeah, for non-approved bounty solvers, or the person could just take the bounty as an insurance policy and say, okay, well, I guess I didn't get what I wanted, but at least I got your money, so I have more money than when I started for my trouble. So yeah, I think that's legitimate, and I think that rounds out the pseudocode section for the main logic. There's going to be some nuts and bolts to plug in. This is going to be a bit of a larger project, but I think it's coming along pretty well so far. This is what a seeker can do, and this is how the seeker can do it. We'll move on to the furnisher next, and I think we'll get some insights into the differences between the different modes of operation. Let me check in, see where everybody's at here with everything. Just checking on the always glad things are starting to get easier to understand. The Metanet is about making the bar lower for developers. A Discord. Haven't really done a Discord in the past. You should join our Slack. If you go to projectbabbage.com, on the top right, you'll see a Slack icon, and you'll be able to ask any questions there on the Slack group. Let me read this here. That would be an interesting model to explore, for sure. But I think that for a simple, this library can be reference code, and somebody can then take it and build something like that. I do like the what is it called? Swiss auction or something like that. Swiss challenge, where any contract awarded, somebody can come in and say, "Hey, I'll do this for less." There are a lot of edge cases, but I think what I'm going to try to do is capture like the 80-20 rule. You could say we want to write 80% of the code, or no, let's see. 80% of the solutions require 20% of the code. The other 20% of solutions require 80% of the code. Therefore, if we write the 20% of the code, that while it's a little bit complicated, it can still cover perhaps 80% of use cases. We can create a generalizable base layer building block that would be useful. It's kind of the idea. Although it does get complicated for sure. And yeah, that's a good approach. There's different things going on, different places, but let me get back to the furniture, so we can start to construct that as well. So essentially, a furniture of services in this context can list all open contracts. They can be constructed with similar parameters to the seeker who seeks services. They don't get constructed with any of these rules. Although, let's see. No, that's a constraint of a particular contract. Constraint of a particular contract, yes. They do have a wallet and a few of these things for sure. I don't think we need that there. And I don't think we even need that here. All right. So in concept, potentially I could filter by work type in the future. So I can put a bid on a contract. Which you'd update the UTXO and register it with the overlay. I think in this case, what we can do is you have a record and you have an amount, you're bidding, and you have the data. What did we call that? It was plans. Okay. So you give the contract you want to bid on. Now somebody has to accept the bid normally. Originally, I was thinking that the bond would only apply when we are disallowing, yeah. So we got contract type, amount, bids. So what this would allow is when you submit a bid, you can put a bond up as well. If, it could be forbidden, it could be optional, it could be required. I'm thinking this could be unified with the other parameter. We got the acceptance time. We got the where's the amount of the bond? Weren't we tracking that? I thought we were already. I don't think we need a new parameter for it. Max allowed bids. I think this should just be bond amount versus having two. This is the required non-approved furnisher bond amount. And this would be the one for approved bonds. Yeah, because I think this is going to be the ultimate form of this contract, is that you can bid and put out a bond. I'm realizing that as I write the logic for it. That way you can say, if I don't do my work, you lose, or if I don't do my work, then I lose this much money. Even when I have to be approved. So there's a whole spectrum of approval versus non-approval on work, and then there's a whole spectrum of the bond being added to the pot, to the stakes of the contract, right? I think all of this is extremely important, because like if I put in a bid that I will do my, that I will do some work for you, and you're going to pay me $500, and then I don't do the work, I should need to lose something, right? I should need to lose a bond amount of, say, $10 at least, maybe even more, maybe even $1,000. I don't know. It really depends, but that should be a thing that's possible. So we got to make sure this is actually, this is actually going to work. Now the question is, no, the bond is added to the contract, so we don't need. This can just be bond amount or required bond amount, right? And it can be optional. Required furnisher bond. So a person can never submit work without submitting their bond, which means eventually, or should they need a bond before they even start work? Yeah, they should. They should need a bond before they start work, which means there needs to be an accept. So I don't want to take everybody's bonds when they bid. So it needs to be a start work pay bond. Right. So when somebody accepts my bid, then the only way that can start is when I post my bond and start my work. That means that the contract state needs an additional for this type, which is going to be like bid accepted. So when I accept a bid, it goes to bid accepted, right? Timer's ticking the whole time for when I want it done. They have to post bond and start work. Posting the bond puts it to active work. If they fail to do that within a particular amount of time, then it goes back to an initial state. So there needs to be another time value, which is the time that the furnisher has to post their bond after their bid has been accepted. Right? Because if I want to cancel the bid, I want to cancel my acceptance of a bid if you don't cooperate within a certain amount of time. As a seeker of services, if I accept you to work on my thing, and if you don't post your bond and start working after I accept your bid by a certain amount of time, like within a few days, depending on what you're doing, could be a few seconds. Well then I'll pick somebody else. So time. So there's got to be already one time value in here. Where was that? Right. So this is the max seeker bounty acceptance time. This is when this is when the seeker must accept this is actually a max seeker it's a payout approval time. I'm approving the payout. And then we also got and everybody's going to criticize my length of my variables, but they're supposed to be pretty clear, I guess. And then we have a max furnisher bond post work start delay. So we're trying to set this delay for how long somebody has to post bond before they start work, so that I can find somebody else who will put up an assurance that if their work is not completed, or if the platform and I kind of side with each other and say, okay, this is not good, then then I get something out. And if they don't post that and start work that way after the bid has been accepted within a certain amount of time, it's going to go back to the initial state, actually. Okay. So that's important. Now we have the full bonding of the furnisher, optionally, of course, and the escrow system is kind of taking shape. So we can revisit our seeker code now that we have this, because we have some changes, right? If I want to seek work. Obviously, we know how to do this. We provide all the parameters. But if I want to get my contract, yep, that's fine. Cancel, fine. I can increase my bounty. I can approve a bid or a bounty solver, depending, right? And there might be a bond associated with that now. Now, I can approve completed work. I can cancel bid approval after delay. That's what we're missing, right? Because if we can cancel the bid approval after a delay, that means that state needs to be bid as accepted. Or wait, should the acceptance of a bid comprise the paying of the bond? Oh, no. How does that work? I put in a bid. I don't pay my bond when I put in the bid because then everybody would need to pay, even if their bid is not accepted. And then we'd have to get the money back to everybody, and that would be a mess. So, yeah, we need this step because of that. We need to allow somebody to post their bond and then cancel the bid if the person doesn't do so. State goes back to initial. Pretty simple, I think. So as a seeker, I want to cancel I can reject a bid. I can cancel they don't post their bond. Got it. Yeah. This is a good way to coordinate state among entities and mediate disputes. So this is how that works. Because I was writing this and I was like, wait, what if I want to bid with a bond? So the bond amount should be part of the bid as well. And it could be, could be something a little bit less, but yeah. Furnisher can now bid. So wait, to place a bid is not to place a bid is not to set the furnisher key. To place a bid is to append to the array. A furnisher can place a bid, start work posting bond if needed. Oh, I see. Populate, aka this. Okay. So I could create a base class and blah, blah, blah. To all of you people who like object-oriented programming that much. Blah, blah, blah. Yeah, I could copy that. It wouldn't be hard either to not copy and paste. So that's essentially every one of these, but verify state is initial. State needs to be initial because, well, that's when you can place a bit. All right. So this one's going to be relatively similar. Oh wait, amount only applies Okay. So this method will apply to a furnisher accepting a bounty or placing a bid. If the contract is a bounty, then the amount of the bid is fixed at the bounty amount. But if the contract is of type bid, then they can actually bid on the contract. And then a contractor can start work on a bid. So escrow record, okay, and you're going to want to verify that your key first the state needs to be is you verify the key is our key. So verify the key is our key. And then if necessary, we increase the contract amount by the amount of what we bidded for our bond that they accepted, or by what the contract requires as the bond if there is a required bond that is fixed. Okay. And then, register the with the overlay. Okay. Whoops. Don't want to do that. All right. Now a person can start work. A furnisher can start work on the contract in theory. Doing all the theory first, and then we'll get hit by a giant brick wall called practical reality of actually writing all of this code. But I think a lot of the theoretical underpinnings have gotten a lot more solid here to actually think through what this would look like in the real world where all of these things exist. Because if you think this is complicated, contracts are complicated. People and incentive structures are complicated. Building these general building blocks will allow everybody to exist without having to merge the complexities that already exist within contractual obligation with the necessary technical complexities of coding all of this up in TypeScript and sCrypt and making it work as a library and having an overlay. Because lawyers should not need to be experts at leveraging low-level BSV blockchain and digital signature primitives. Although for what we pay them, maybe. A furnisher can mark work as completed, changing the state from the active work state to the submitted work state. Can they submit work product? Well, maybe that's a thing that happens. Maybe there's a message that is sent to the person, and maybe there's a work product hash in the, even a salted hash. That could be good. Salted hashes are pretty secure. You should add that to the data structure. If there is to be a work descriptor, there will also be a work completion descriptor. It might be a hash. It might be. We'll figure that out, right? We'll figure out all these details, what these might be, but there should be some record of what was supposed to be done and then what was submitted. Both, right? And that should be linkable back to the chain, whether it's encrypted, hashed, public plain text in the case of most government contracts, I would hope. Who knows? Except for the secret ones. You don't want to publish the secret ones. That would be really bad. Let's see, async. And we want to say finish work. So you got a record. And you want to verify the state is active work. Verify the furnisher. We are the correct furnisher of these services in this contract. State goes to, and then of course we just added this. So state goes to submitted work. Add the work completion descriptor. Update the UTXO on the overlay. Okay. Now it's submitted. You could send a message to the seeker containing maybe an encrypted version of the thing that is salted and hashed and put into the contract as the work completion descriptor so that the seeker can evaluate the work having been completed. Okay. So that's going to be the complete work function, which basically ends. Oh, wait. So if I complete work, I need to approve completed work. And that happens on the other side, which we already coded, I think, or pseudo-coded. Okay. Receive pay for approved work, raise dispute, list disputes, claim money from dispute. Yeah. So first we got to get paid. No, we can't do that. So this is going to be verify, verify, verify. State is resolved. We are the correct key. Spend the UTXO into our balance. Okay. All right. So what's my grievance as a worker? If I provide services to somebody and I mark my work as submitted, and they don't approve it, my work was submitted and I can't do this because they won't approve of this happening. Right? So after I submit my work is when I have a dispute. They're not paying me. So the state of a contract needs to be in submitted work state or, yeah. Submitted work. And then I raise a dispute. I see. So if I'm disputing the platform, I already have my signature, meaning if I raise a dispute, the platform may release the funds to me. Now there needs to be a delay. Yeah, we already thought about this, right? This is what I was getting hung up on. How long does the seeker have to review and accept my work before I can raise a dispute? Well, there is this max seeker bounty payout approval time. I think that would be the. I think I'm going to get rid of the word bounty out of here, though, because it applies to actually everything. I didn't realize that until now, but it certainly does. There is a number of seconds that the seeker has to approve. Could be a lot of seconds, could be a few days, could be years. Well, that'd be a really long time. But the seeker has a certain amount of time to approve after work has been submitted before the payout is made. The dispute can happen only after that. So we want to confirm in this one. Verify status submitted work with our key. Verify seeker payout approval time has elapsed. State goes to furnisher dispute. Update UTXO on overlay. All right. I want to list all my active disputes. I can do that with the same function as I have in here. And that's list available work, right? And this is all pseudocode still. Pretty simple. I'll also add that. I think I didn't add that to the other one. And then I can receive money from so I can list active disputes, okay? And then same like this, I can, as a furnisher of services or products, and then it doesn't make sense. It's not reclaim, it's just claim after dispute. And there's no concept of reconstitution here. The contract is just settled against the wishes of the, the platform sided with the furnisher in this case. Suspend the resolved UTXO, very simple. And I think that's all the pseudocode for all of the stuff with the furniture. Platforms can list disputes needing attention and adjudicate. And when they do, they claim a fee. The rest of the money goes to the winning party. And it should be possible, perhaps, for the platform to decide, that's interesting. What if the platform says, well, I don't know, but I think you were probably at fault, so I'm going to give 70% of the money to one and 30% to the other? Or is that a thing we should support? It should be an optional Boolean. Can the platform make flexible awards? Can the platform do that? Is it allowed, or must they decide? Platform must be fully decisive, true, false. So if they must be decisive, they must decide that one person gets all the money and the other person gets none of the money. If there is an element of uncertainty or compromise, then they may not be decisive and they may choose to award 50-50. They may choose to award, 70-30. I don't know. Must they be decisive? This is an element of dispute resolution. You get 30% of your money back because maybe you did get your package delivered, but it was just a little late. That's a thing that could happen. We should acknowledge that reality in the code that we write. The more code that we write in acknowledgement of the real world and how things actually work, I think that's better for pretty much everybody in the world. Maybe that's wrong, but who knows? Let's see. We need a platform. Platform has a wallet. It's got some configuration parameters. It can look on the overlay. It can make topical broadcasts. It can derive keys and do signatures, etc., etc. It's got a derived public key. It's got all the same things that everybody else has, except cannot do that. It can only list active dispute. So we list. It's already. So where we are the platform key. Place bid. Nope, doesn't exist. Right? I can adjudicate a dispute. That's the only thing I can do as a platform. And I recognize that I already have a function called list active disputes. Decide dispute. Now I know that I've used a lot of very complicated long variable names, but I'm not going to try to spell adjudicate. So given a dispute, see, amount for seeker, amount for furnisher, disputing party Okay, so the forcing function here is that the platform cannot take the money for itself. But in the case that a dispute has already been raised, so verify states it's in dispute, meaning somebody needs the platform involved. Platform may not side with you at this point, but now the platform's going to decide. The platform, in fact, cannot be involved unless somebody raises a dispute. At least in the current implementation, somebody could implement a version of this where the platform freezes something. It could take a contract that is actively being worked on and it could reach in the middle and say stop work order. Just in the from on high. Somebody could build that. But here we're thinking more about dispute resolution and escrow. So we know the states are correct and we just allocate the there's no new UTXO. Wait. How would that work? The old system constrains that the money must be paid. We continue to add features. For example, this non-decisive escrow type idea, which complicates things because you need additional states. Or you could say at this point that the UTXO is decomposed, messages are sent, yeah, that's actually a better way to. So the dispute resolution happens when the platform decides what's going to happen, and UTXO is split across according Okay, so messages get sent via message box to both parties in this case. We can see the messages here in this case. Now, the issue here is the methods, the architecture of the methods. So in the seeker, when I want to get paid from a dispute or reclaim after dispute, what happens is I don't spend the resolved UTXO. That only happens when the state only goes to resolved when the contract ends according to the satisfaction of both parties. The dispute destroys the contract in its current state, the way we've built it here, because we want to support additional payout regimes, which are easier to support in that way. So what we need to do is there is a disputed record. How does that work? This is gonna how do we get a list of all the disputes that we have? When we raise a dispute, it goes to the overlay. The dispute is only active when okay, records of past disputes are stored in local baskets. So we're going to use every state management system. Messaging between the parties when there's a dispute. Local baskets for historical record keeping after a dispute. And overlays for general coordination. So got it. Okay, that's how that's going to work. You're going to list your disputes based on what's in your basket and what's in there. When you want to reclaim after a dispute, you're going to list the messages from your disputes message box that came from the platform. You're going to internalize any outputs that you got from a dispute. Make record of that in that way. And then if you want to reconstitute, then you reconstitute. All right, but this architecture, this part of the architecture is what's going to be across this one and this one. This is going to be claim after dispute, and it's going to take a record. Just going to overwrite. So now we have the same way to list disputes and claim after dispute across both of those. And then we need some comments in the other one to re-architect that properly. All right, so the architecture is complete. I mean, largely. Okay, so we just need to have a way to get things out of the basket here. So to decide a dispute, send the notes to both parties if you want about why the dispute was decided the way it was. And the messages sent contain either the denial or the payout transaction. New UTXOs get created according to the outcome. Contract rules still enforce the constraints. So in this case, the provider gets only a certain fee and the certain, whether they have to be decisive fully or they can allocate, So this has been the high-level architecture for this dispute resolution system. I think it's feeling pretty solid. And then for list past, this would essentially just list the local. Right. Okay. So I've been live streaming for just about, I think, 3 hours or something. And we have the complete architecture, right? So this is all the pseudocode has been written and mapped out. We don't have contract methods, but we do have how each party uses each aspect of the system. So to summarize before we close, and then I'll check out the chat. So post any questions now if you'd like before I. Oops, I don't want to do that right now. Before I end, what I'll do is I'll give a summary of what we have so far and how each part of the system is architected, given this sketch that we've made thus far to really nail down what a generalizable toolbox for escrow contract composition on the metanet might look like. From the perspective of a seeker, a person who wants to have some product or service given to them, and they're willing to pay for it. The seeker cares about things like all of the contract configuration parameters, right? They care about, what wallet they have, obviously, who they are, and how they're going to interact, basically. And they can seek, meaning they can put a contract out into the world where they're saying, here's what I want done, and here's how much I'm willing to pay for it. Or they can just say, here's what I want done. I'm accepting bids. Please submit your bids, and I will, and I will consider accepting them. To do that, they will construct the new contract. If there's only bids, then they'll put 1 sat for now, just a small token amount. Otherwise, they will put the full bounty amount that they're willing to pay for the completion of the services. They'll create the transaction and put it up on the overlay. A seeker can get their own contracts from the list. So they'll just ask the lookup service to return everything that they have currently going on that's active. They can cancel before anybody accepts their contract, of course. They can increase the bounty in case it wasn't high enough to begin with. They can approve bids that people have made. Or if somebody comes along and they just want to claim the particular bounty, they can approve that person to go ahead and start working on it, which makes it exclusive at that point. Bids can contain bonds. So a person who bids on a contract can put up some of their own money and say, if at the end of the day I don't meet your requirements and the platform decides that that's the case, then I lose my money and you get it as a bond. This applies to bids and bounties, of course. The seeker of services can cancel a bid approval after a delay, supposing the approved person fails to post the necessary bond in time or accept the contract and begin work. The seeker of services can also approve completed work on a contract. And that would bring the UTXO state to resolved, allowing the person to receive money when it is complete. That goes onto the overlay. The seeker can dispute work as long as the furnisher of products or services did not complete the work in time. They could also dispute the quality of submitted work. That sets the contract state to disputed, goes on the overlay, and then we send a message to the platform letting them know, hey, somebody didn't do me right. I can see a list of all of the active or historical disputes I've been involved with. And if the platform sides with me, I can reclaim my money after successful dispute. That's what a seeker can do. If I am a furnisher, I am a person who furnishes products and services in this framework. I have a wallet and a way to interact with everybody in a common set of protocols. I can see current work that is available, and eventually I'll be able to filter it by the type of work I'm interested in doing. I can place a bid, which optionally has a bond, meaning I can put up some money or indicate my intention that were this bid to be accepted, I would put up a bond. And my bid can have an amount. Sometimes the amount is fixed in case I am bidding on a bounty style contract where the seeker has already established the amount of money that they're going to offer. But if not, I can say how much I'm willing to bid in order to complete this work. So, the bid gets added to the list, and then it goes up on the overlay for additional people to continue bidding on if desired, up to the max number of allowed bids. If my bid is accepted, I can start work. So that means I would post my bond actually at this point. And if I fail to do so within the agreed amount of time, then my bid will be canceled. And maybe there's something there where eventually the platform or something like that could get involved if say somebody didn't they kept bidding on things without the intention to actually do them. I guess maybe the seeker might not select that particular individual if they know they're not serious. Then work can be completed. So after I am finished, I provide proof in the form of a completion descriptor of my work that I have done. And then it goes back on the overlay so that the seeker of the services that I have just finished providing can now pay me for what I've done. And of course, the money is already in the contract at this point. It's not like they don't have it. It's been posted. It's just they've got to sign off. If they do sign off, then I can claim my bounty and I can go about my day. And if they don't sign off, and if the time has expired where they should have signed off by a particular amount of time after the end of the contract, then, well, I can raise a dispute. I can see all of the disputes that I have been involved with in the past or that I am currently involved with, or both. I can claim money that I receive after a successful dispute. That's how it works. If I'm a platform, my role is to resolve disputes among the seekers and furnishers of products and services within the context in which I am operating. A platform is constructed with the exact same set of parameters as a furnisher, meaning just a wallet capable of interacting and a set of protocol primitives. I can see the currently active disputes from the overlay by seeing which ones have tagged with my platform key. I can see my historical disputes that I have decided, and I can decide a dispute, essentially allocating funds according to the pre-agreed upon stipulations among, well, did this person do this work? Did they not? Who gets what amount of money? And that is everything that a platform would do in this model. We would now proceed to the implementation of the smart contract methods as pseudocode and then translate everything from pseudocode into TypeScript and sCrypt, and then write some unit tests, and then ship an NPM package, and then use the NPM package within a React application after first deploying the overlay service using CARS, the Cloud Automated Runtime System. Those would be the next steps to complete this project. When I started this live stream, I didn't think it would take this long to get where we are, but I wanted to make sure that I was thorough with all of the things that need to be part of an escrowed contract in a generalizable way. And I think I got there, or at least pretty close. The one thing I think I should add is a min bid amount. There's always going to be little things, right? If you bid below a certain amount, your bid cannot be inserted into the contract. It won't happen. Right? To summarize what I've come up with for this contract, an escrow obviously has a current UTXO associated with it, a max number of allowed bids, a minimum bid amount, the percentage of the contract amount that would go to a service provider in the case of a dispute, the stipulation as to whether the escrow service platform must be fully decisive in the sense of giving all of the money to one party or the other party, or whether they might be able to sort of split the baby because they're uncertain, or because perhaps a service was partially provided or not to full satisfaction of the initial terms, but where it would be unfair to fail to compensate at all or something. The next parameter relates to whether a bounty solver needs approval. So in a completely open system, bounty solvers would not need approval, and they could just work in parallel to compete. And whoever calls the contract first and says, hey, I have this solution, well, they put up a bond, and if they didn't have this solution, eventually they would lose that bond. So this allows for a lot of open-ended type contracts where people are trying to solve something. This is related to the bond mode of the furnisher. In forbidden mode, a furnisher may not put a bond associated with their bid. In optional mode, they may, but they don't have to, and the bond can be of any amount. In required mode, a fixed amount of money is required as a bond with every bid that is submitted. And here is the value for the required bond to be submitted in this case. This value applies both to whether the contract is, an open-ended bond type contract where somebody could claim it at any time without approval, or whether and they would need to post a bond of this amount, or whether in required mode for the furnisher bond, the amount would be controlled by this value in that case. This value relates to the amount of time that the furnisher has to post their bond after a bid has been accepted. And this value relates to the amount of time after work has been submitted that the seeker of the work has in order to approve the work before a dispute can be raised by the furnisher. And this value relates to the amount of time that must elapse from when the work starts until the seeker of the work can claim a dispute for not being done on time, essentially the deadline, right? How long does the furnisher have to complete the work? At what time will this work expire? Uh, this value relates to whether the seeker, the platform, or both may approve work to be done. Currently, this is not implemented, but we can certainly add it to the platform side, where the platform could be involved with the approval of bids or the uh, approval of a solver in the case of a bounty contract, uh, either uh, together with, maybe it could be either one. It could be just the seeker who may approve, or it could be the platform that's the only one that might be able to approve. So the approval mode. This value controls the type of the contract. Of course, with bid-based contracts, the amount is not stipulated up front, whereas with bounty contracts, it is fixed and not subject to negotiation. If there is a bounty amount, this value controls the amount of the bounty. The next value is an array of all of the bids that have accumulated. So the seeker. No. This is this is the public key of the furnisher who would seek to who would bid on the services to try to provide them. We've got the plans, which would relate to any specific things that the furnisher would do in furtherance of completing the services. You've got the amount of the bid, and then you've got a bond amount. So how much are you going to stand to lose if you fail? We track that which bid has been accepted, the public key of the person who is seeking the services to be completed, the public key of the dispute resolution platform, and the public key of the furnisher, which will be known and installed once a bid has been accepted. We also keep track of the description of the work, which might be arbitrary data. So what does the seeker want to be done? What work should be completed? And then what description should be applicable to the completion of the work? This is to say, what work product has been made by the furnisher. And finally, we have our state tracking system. The contract starts in the initial state. It goes to bid accepted once the seeker is ready to select among the particular people who seek to perform work. It moves to active work state once the selected bidder posts the necessary bond. It moves to submitted work once the selected bidder has submitted what they purport to be completed work. And it moves to resolved once the seeker has signed off on the work having been completed to their satisfaction. It can move into disputed by seeker if after the work deadline work has not been completed, or after the work has been submitted, it is not to the satisfaction of the initial seeker of the work and their initial requirements. And it can move to disputed by furnisher if after the amount of time allotted for review of submitted work, the contract is not, they're not getting paid. It hasn't been approved. And that's it. That's all of the things that can happen in this contract. In this architecture, I should say, because we didn't write the contract yet. We didn't write hardly any code yet, but we did do a lot of architecture. And this foundational architecture will now be applied. We will work in the future to make this into a real thing that people can use. You don't, of course, have to use all of the features. You could create very simple systems that leverage this library, or you could create more complicated systems that leverage more of the advanced features, or even fork the library to add your own. For example, the Swiss challenge that Ishan suggested previously. So I hope this has been useful. Let me pull up the chat if there is any additional things. Let me see here. So, just checking. No. All right. Well, one day we will have this system completed, and we'll be able to implement this particular method. I personally think it would be a good method to implement. Let's see. All right, I think that is about everything I wanted to talk about. I hope this has been useful. I will push this code. That's actually one thing I should do. Let me do that immediately so that everybody can see what we've just been working on. Let's just make sure we're not going to commit node modules. We will commit the initial scaffold. Do I have to make a new repository? I think I probably do. But it will be open source under the OpenBSV license. Where's my, here we go. So let's just go and make a new repository, Babbage Escrow. Building blocks for escrow systems. This will be a public repository. And now, if I just do that, then the repo should be live. All right, and it still says meter for the new world. Let's change that. I can't live with that. No. What? Oh. Oh, goodness gracious. Let's see. At least we'll have the README correct. And boom. Let me just toss this in the chat. Can this be sent? I think so. There's the repository, everybody. Let me confirm that. All right. The repository has been made live. Babbage Escrow. It's a high-level sketch, but I will continue to hydrate it with actual code. And now we have an architecture for escrow that will actually work. So I hope you enjoyed, everybody. Be sure to subscribe to the channel and go on X, follow us on X. all those other things that everybody's supposed to say at the end of live streams on Web 2.0 as we build, uh, you know, Web 3 and fun stuff and better stuff. I think there's going to be a lot of use cases and applications on top of resilient escrow, for example. So I figured we would create this library to demonstrate how to do that. I'll probably work on this a little bit off stream just because there's a lot of, I wanted to do the architecture though. I wanted to talk through the design, and then you'll be able to use it, right? So I'm going to have the docs and everything. I'm going to have all the code written. There's going to be an overlay, it'll be reference implementation that everybody can use, and I'll get that done as soon as I can. And that way we have an escrow system, because the world, the BSC blockchain, the Metanet, it's a darker, duller place if we don't have an escrow system that works. So thanks everybody. Talk soon.